In 2014, scientists and researchers unveiled an updated and highly precise map of the ocean floor. This revelation brought to light thousands of underwater mountains and volcanoes that had previously remained unknown to humanity. The data harnessed for this groundbreaking map-making endeavor was collected through the use of two satellite observatories, the European Space Agency's Cryosat-2 and NASA's JASON-1, which was operated in collaboration with the French space agency CNES. Both of these observatories were equipped with instruments capable of measuring the ocean's surface topography with incredible precision. Leading this significant study was David Sanwell, a geophysics professor at the Scripps Institution of Oceanography, UC San Diego. He emphasized the significance of this discovery, noting that it might not immediately strike as a major development. However, the revelation was substantial. Instead of merely identifying 5,000 volcanoes beneath the ocean's depths, they had now identified a staggering 10,000. This newfound knowledge about underwater volcanoes holds immense importance given humanity's historical encounters with volcanic eruptions. Throughout history, volcanic eruptions like Pinatubo, St. Helena, Pompeii, and Krakatoa have caused extensive fatalities and widespread devastation in their wake. More recently, the world experienced the 2022 eruption of Hunga Tonga, the largest volcanic eruption of the 21st century. This eruption sent shockwaves rippling across the globe, striking fear even into the bravest among us. However, it is crucial to recognize that such events are not isolated incidents. In recent decades, both above-ground and underwater volcanoes have been reawakening from their slumber. The Hunga Tonga eruption of 2022, though significant, is not an anomaly. History has witnessed even more devastating volcanic eruptions. What's particularly concerning is that underwater eruptions have the potential to inflict even greater damage than their above-ground counterparts. The largest recorded underwater eruption, which took place in 2018, gave rise to a colossal phenomenon resembling the birth of a giant baby, an underwater volcano towering to skyscraper proportions. Similar to their terrestrial counterparts, submarine volcanoes are essentially fissures or vents in the Earth's surface through which magma can spew. The key distinction lies in their subaquatic existence. Many submarine volcanoes are strategically situated near the mid-ocean ridges, where tectonic plates converge and form anew. These volcanoes, nestled within the mid-ocean ridges, contribute significantly to Earth's magma output, accounting for over 75% of it. While most submarine volcanoes reside deep within the ocean's abyss, some inhabit shallower waters, capable of ejecting volcanic material into the atmosphere during eruptions. Astoundingly, scientists estimate that there may be around 1 million or more underwater volcanoes, with a majority deemed extinct. Approximately 75,000 of these submerged giants rise over 1 kilometer from the seabed. Astonishingly, some of the planet's most active volcanic systems remain concealed beneath an average of 2,500 meters of water. These subaqueous volcanic eruptions, expelling magma and lava, sculpt the boundaries of emerging oceanic plates and furnish heat and essential chemicals to Earth's unique and rare ecosystems. Water's presence significantly influences the characteristics of volcanic eruptions beneath the waves. The presence of water expedites magma cooling, transforming it into volcanic glass. Consequently, the textures and shapes of lava produced by submarine volcanoes differ from surface eruptions. At ocean depths surpassing 2,200 meters, water pressure surpasses the critical pressure of water, preventing it from boiling. Instead, it transitions into a supercritical fluid. This absence of characteristic boiling sounds complicates the detection of deep-sea volcanoes over vast distances, hampering the use of hydrophones for this purpose. Our understanding of the whereabouts and activities of underwater volcanoes remains incomplete. Nonetheless, scientists have discerned that many of these submarine volcanoes take the form of seamounts, which are typically dormant volcanoes rising abruptly from the seafloor, typically at depths ranging from 1,000 to 4,000 meters. Oceanographers define seamounts as independent features that ascend at least 1,000 meters above the seafloor. Astonishingly, an estimated 30,000 seamounts are dispersed worldwide, yet only a limited few have undergone in-depth examination by experts. In 2018, the scientific community was alerted to enigmatic seismic rumblings detected by seismometers worldwide. These emanated from a relatively tranquil region in the Indian Ocean, positioned between Comoros and Madagascar. During that period, researchers made a remarkable discovery that left them astounded: an underwater volcano towering at a height of 2,690 feet, equivalent to 1.5 times the stature of New York's One World Trade Center. This colossal volcanic formation was the outcome of the most extensive underwater eruption ever recorded. Scientists hypothesize that this volcano sources its lava from the deepest known volcanic magma reservoir recognized by researchers. The journey of revelation commenced in 2018, when seismic disturbances captured global attention, originating nearly 31 miles east of the French island of Mayotte. These seismic rumblings, characterized by low-frequency earthquakes, reverberated across seismometers worldwide. This underwater behemoth startled the scientific community, especially considering that only 2 seismic occurrences had been recorded in the vicinity of Mayotte since 1972. Prior to this, the sole indicator of eruption was a layer of 4,000-year-old pumice discovered in a nearby lagoon. In response to this enigma, researchers swiftly deployed ocean-bottom seismometers and GPS systems to monitor geological activities. Notably, they observed that the island was gradually shifting eastward at a rate of 7.8 inches annually. As they delved deeper into the origins of these seismic tremors, the research team meticulously scrutinized an expansive seafloor area encompassing over 8,500 square kilometers adjacent to Mayotte Island. The team remained cognizant of a magmatic event occurring east of the island, yet the nature of this event remained shrouded in uncertainty. Whether the magma remained concealed beneath the crust or erupted onto the seafloor was unclear. Their suite of monitoring equipment detected an astonishing 17,000 vibrations emanating from depths spanning 20 to 50 kilometers below the sea crust. Employing the comprehensive dataset they had amassed, the research team meticulously analyzed the seismic waves captured by their instruments. Through this analysis, they pieced together the intriguing story of how this underwater volcano came into existence. The region had previously exhibited an almost level topography before the emergence of this colossal volcano, located 8,464 feet below sea level. Strikingly, this massive seamount had eluded detection during the 2014 geological survey conducted by France's Naval Hydrographic and Oceanographic Service. The formation of this gargantuan submarine volcano stemmed from a colossal magma reservoir situated just beneath the Earth's crust. Tectonic plate movements initiated the fracturing of the crust, facilitating the ascent of magma and the creation of geological dikes, rocks that filled extensive voids while intersecting the surrounding layers of rock. This process was responsible for generating the seismic activity, and once the magma reached the seabed, the volcano began to take shape as its reservoir of lava gradually drained. Scientists continue to closely monitor the tremors and volcanic events in this region. The most recent detection of magma on the ocean floor was made by researchers in January 2021. The source of this volcano's magma reservoir lies approximately 55 kilometers beneath the Earth's surface. Nathalie Fourier, a marine geoscientist affiliated with the Paris Institute of Earth Physics, IPGP, at the University of Paris, emphasized the groundbreaking nature of this discovery, marking the first time in volcanology that such a deep reservoir has been visualized. The magma reservoir beneath this volcano yields a volume of materials estimated to be between 30 to 1,000 times larger than any other documented deep-sea eruption. This immense eruption dwarfed the 2012 Harvard eruption in New Zealand, exceeding it in size by more than threefold. Furthermore, it surpassed Iceland's Bardarbunga eruption of 2014 by about 2.5 times in magnitude. What adds to the intrigue is the belief among experts that this isn't the first eruption near Mayotte. Evidence in the form of substantial lava flows and cones on the upper slope and onshore areas of Mayotte suggests that similar events have occurred in the past. Notably, a few years ago, scientists identified a volcano in the Pacific Ocean, situated nearly 1,600 kilometers east of Japan. This submarine volcano is not only the largest on Earth but also ranks among the largest in the entire solar system. Initially perceived as a composite of smaller structures, The Tamu Massif, as it's called, was ultimately recognized as a colossal single volcano. William Sega, a geology professor at the University of Houston in Texas, drew parallels to the renowned Olympus Mons on Mars, underscoring that the Tamu Massif stands in the same league. This rounded dome-shaped giant spans nearly 480 by 650 kilometers, with its summit lying almost 2,000 meters below the ocean's surface and its base extending to a depth of 6.4 kilometers beneath the seabed. The Earth's largest surface volcano, the towering Mauna Loa, pales in comparison to the colossal underwater behemoth known as Tamu Massif. This underwater giant, crafted from basalt, stands as a monumental and time-honored feature within the Shotskis Rise Oceanic Plateau, located in the northwestern Pacific Ocean. Although scientists initially charted this underwater rise back in the 20th century, they possessed scant knowledge regarding its internal structure or the processes underpinning its formation. Tamu Massif, in its distinctiveness, diverges significantly from the conventional seamounts that punctuate the ocean floor across the globe. It distinguishes itself by its vast proportions and notably gentle slopes. Its summit exhibits a mere 1-degree incline, while the slope dwindles to half a degree down its flanks and even less at its base. Yet, what truly astounded researchers was the seismic data unearthed from Tamu Massif. Among the seismic revelations, investigators discerned what appeared to be lava flows radiating outward from the volcano's core. Intriguingly, they struggled to locate any conspicuous secondary source of volcanism. Scientists have since posited that Tamu Massif originated from a singular volcano during a relatively concise timeframe, ultimately becoming extinct shortly after its formation. According to William Sega, this transformative event likely unfolded during the late Jurassic to early Cretaceous period, approximately 145 million years ago. One can only ponder the implications had this colossal entity remained active and erupted. Fortunately, Tamu Massif now rests in a state of dormancy. However, it is noteworthy that a vast region in the Pacific Ocean continually experiences multiple volcanic eruptions and frequent earthquakes. Renowned globally as the Pacific Ring of Fire, Rim of Fire, Girdle of Fire, or Circum-Pacific Belt, this horseshoe-shaped expanse spans approximately 40,000 kilometers in length and extends over 500 kilometers in width. Encompassing the Pacific coasts of North America, South America, Kamchatka, and several western Pacific Ocean islands, the Ring of Fire finds its origins in the dynamic realm of plate tectonics. Specifically, it emerges from the intricate interplay of lithospheric plate movement, collision, and subduction beneath and surrounding the Pacific Ocean. This ring of volcanic and seismic activity, however, does not form a continuous structure throughout its extent. Nonetheless, volcanic eruptions within the expanse of this ring manifest independently from those in its other sectors. Remarkably, this ring alone encompasses approximately 2/3 of the world's total volcanoes, boasting between 850 to 1,000 volcanoes that have exhibited activity during the Holocene epoch. In fact, the 4 most prodigious volcanic eruptions recorded on Earth during this epoch all unfolded within volcanoes nestled in the confines of the Ring of Fire. Alongside the currently active and dormant volcanoes, this region also harbors belts of much older, extinguished volcanoes that emerged eons ago. One such notable example is Ojos del Salado, the world's loftiest active volcano, ensconced within the Andes mountain segment of the Pacific Ring. This towering geological giant last erupted in the year 750 AD. As per experts, an astounding 76% of our planet's seismic energy surges forth in the form of earthquakes within the Pacific Ring of Fire. Situated a mere 60 kilometers from the island nation of Tonga, the Hunga Tonga Hunga Ha'apai volcano's eruption this year had perplexed scientists. Initially, the cause of this underwater volcano's explosiveness remained elusive, but now researchers are gradually piecing together the puzzle. Evidence gleaned by 2 distinct teams has illuminated the eruption's mechanics. It transpired that during the eruption, the volcano discharged an immense volume of magma, provoking an explosive reaction with the surrounding water. This, in turn, triggered a series of substantial detonations and hundreds of minor explosions. Collaborators from Tonga's Deputy Secretary for Lands and Natural Resources in Nuku'alofa contributed to this research, shedding light on the volcano's mechanisms. An expedition conducted by a team from New Zealand's National Institute for Water and Atmospheric Research analyzed the ash produced by the explosion. They ascertained that it was accompanied by dramatic pyroclastic flows, turning the seabed into an extensive desolation, obliterating all in their path. These flows extended for thousands of square kilometers underwater, tearing apart undersea cables, including those vital for Tonga's internet access. The sediment from this ash is believed to be so toxic that it is unlikely to support even bacterial life. Experts harbor the hope that this extraordinarily potent eruption was an isolated event, as humanity is ill-prepared to cope with further occurrences of such magnitude. The question arises: will eruptions of this nature become more frequent in the coming centuries? Share your thoughts in the comments below.